Hi everyone, this is Sunny Kumar from IIT BHU. Welcome to my channel Code with Sunny, and today I am going to discuss the problem missing number. Index number is 268 of Leetcode and the problem is of easy type. So let's jump directly into the problem statement without wasting our time. We have been given an array nums containing n distinct numbers in the range. So every element must have a frequency 1 and the elements must lie in this range. We have to return the only number in the range that is missing from this array. Okay. So there is a follow-up also here. Can you implement solution using O of 1 extra space complexity and O of 1 runtime complexity? Okay. So let's try it out. So we have been, let's see the constraints, and nums dot length n is varying up to 10 power 4 and each number lies between 0 to n, both inclusive. All numbers of nums are unique. Okay. So how we are going to do this problem? So let's move further. So what is actually given in this question is given an array of elements, and where the size of the array is n, an array of I is must be lying between 0 to n, both inclusive. We have to find the missing number in the array. So what should be our goal in this problem? We have to find the missing number if in O of n time and O of 1 of space, O of 1 extra space. Okay. So let's go further. Let's understand this problem with the examples. Note that I am going to use two methods to solve this problem in most efficient way. Okay, so let's move further. So what I'm going to do is note that every element of the array must lie between 0 to n inclusive. So I'm going to find the sum of the array, or you can say I'm going to find sum found. So should be the sum found? This should be like 9, okay, 9 plus 6 plus, okay, I'm going to write in very fast, 9 plus 6 plus 4 plus 2 plus 3 plus 5 plus 7 plus 0 plus 1. This is the sum found, that is sum of the array, and it should be the sum, the expected sum minus the what, the missing number. This should be our sum found. If we calculate this sum found, we can easily calculate the missing number too. And if we found this, what should be the value? 9 6 15 4 19 plus 24 5 29, and this 36 plus 37. This is my sum found of this array. And what should be the expected sum? That is, if all the numbers are present, that is sum from 0 to up to what? Sum from 0 to up to 9. So what should be the sum found? That is simply 9 into 10 upon 2. That is 45. This should be our sum found. That is, this contains, that is expected sum contains every element a single time, including the missing number. And if we subtract expected sum minus sum found, we will get the missing number. So what should be our missing number? Missing number is just simply, you can write expected sum minus sum found. This should be our missing number, that is nothing but 8. You can easily see, if we list all the elements of the array sequentially, that is from 0, you can see 8 is the missing number that is not present in the array. So this is my basic first approach. It would take O of n time because to traverse the array, and O of 1 space, extra space, because I'm not going to use any extra space. Okay. So let's discuss my second method, that is using XOR concept. So what should be the basic requirement, or you can say the methodology to solve this problem using the help of the XOR concept? We can see, if we pair two elements, let's say we have an element, say num, and if we take XOR with again this number, you can see this will come out to be 0. If two numbers are present and we take XOR of the two numbers and the two numbers are same, then the XOR will come out to be 0. And what should be the XOR of this one? Let's say num, and then again let's say n. And what should be the XOR of this number? This number is basically, we can do this by applying the rules of associative. That is, you can do this like this: num XOR then n, which is nothing but basically 0 XOR n, which is nothing but n. Now this concept I am going to use to find the missing number in this case. How we are going to find this missing number in this case? So my first approach would be take XOR of all the elements of the array. I'm going to take the XOR with all the elements of the array. And if I'm going to take the XOR with all the elements of the array, let's say we have the variable as answer, that you, or you can say have the variable as current now. Now let's say this is going to denote the XOR of the all the elements of the array. Now I'm going to take XOR of all the values, that is I'm going to take the XOR of all the values from 0 to n, both inclusive. I'm going to write this one, okay, both inclusive. Now why I'm going to do this, and because if I'm going to take XOR of all the elements, every element must have the frequency 1 till now, and if I am going to take the XOR of all the values from 0 to n, every element frequency becomes 2 except the only one element whose frequency will remain 1, that is the missing number, okay. And if you consider this example, so I'm going to write is, after doing the very first step, that is take XOR of all the elements of the array, it would be like 9. I'm going to write 9 XOR 6 XOR 4 XOR, and then 2 3 5. Let's write fast. 2 3 and then 5, and then 701 701. Okay, yes. Now this is basically the XOR of this is basically the value after I'm going to attain after doing this very first operation. So let's do some more tricky. That is, I'm going to do the next thing, that is I'm going to take XOR with this one, with again from all the values from 0 to n, both inclusive. And if I am going to do that, note that the 8, which is our missing number, comes in our second parameter, but 8 doesn't comes in our first parameter. That is, if the frequency of all the elements whose frequency are going to be 2 get the value 0 on doing the XOR, and if the missing number has frequency 1, and this will give our missing number, because if the missing number will have the frequency 1, all the XOR values will become 0, and if 0 XOR missing number is our missing number. So this is the basic idea of our this approach. So let's move further. That is, I'm going to discuss my first approach. Calculate the expected sum, that is sum of the numbers. Then calculate the sum of the array, which is our sum found. Missing number will be expected sum minus sum found. Time complexity of this approach is O of n. Space complexity is O of 1. And my second approach is XOR concept. We all know that XOR of the two elements, that is, or you can say the pair of three elements, A XOR B is equal to A. I am going to use this concept, that is make all the elements frequency twice, and if the missing number will have the what in the missing number will have the frequency equal to 1, so that will be our answer if you take XOR of all the elements, okay. Now take XOR all the elements of the array as well as the values between 0 to n, both inclusive. Our answer will be simply the XOR of the above taken numbers. Yes, it would be. So our time complexity would be O of n in this method, and the space complexity would be O of 1, since since I'm not going to use any extra space. So let's move to the code. Okay, I've already done something like stuff. So let's see this out. So this is my very first method, that is using the sum. Okay, what I have done is I have find the expected sum, which is n into n plus 1 upon 2. Then my sum found will be the sum of the array. I have used here accumulate function. Then I have returned the expected sum minus sum found. Okay, so this is my first method. So let's open my second method and check it out. Okay, this has a runtime bits of 91% faster than. So here what I've done is I have taken the answer as nums dot size, because I'm going to index from 0 to n minus 1, so it's better to store the value n as in our answer. So I'm going to take XOR with every time the previous values up to till now, XOR the current number, XOR the index. That is, you can say from 0 to n. That's what I'm going to do here. And finally, I'm going to return the answer, which would be our missing number. So if you have any doubts, do not forget to mention in the comment section of the video, and the link to the code for both the approaches is mentioned in the description section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.